Hi everyone, can you hear me?
Yes, we can hear you.
Great. This is Guan. So I'm a senior data scientist working for Swiss Re. I actually just recently relocated from Hong Kong to Singapore. And frankly, I've been working from home since the start of this year because of this coronavirus lockdown. But that's good because you spend more time with your family and you can actually be more focused on a bit of development work. So today my topic is about building a Chinese chatbot. It's data, algorithms, and tools, but basically I will try to cover a bit of the related topics in NLP. This is the agenda. So I will first talk about what is NLP, what is tasks, and then I will cover a bit of chatbot for vertical domains, and at last I will show you a tool that we built. Maybe if we have time, I can demo a bit. I put a picture of a cake here just to show you that chatbot is just like this cake, and all the different algorithms and tasks are just like the different ingredients of that cake. And because of the development, the more advanced development of all that algorithms, now we can actually deliver a very delicious cake here. For today's talk, I will focus a bit on the Chinese version of this cake, but of course, you know that the most advanced cake would be the English NLP there. So let's jump right into it. The first one, NLP tasks and algorithms. So before I really talk about what NLP tasks is, I would like to bring up this very important concept of word embedding. From my point of view, the development of word embedding or the invention of word embedding is really a separation, a milestone of NLP research, natural language processing research. Because before the word embedding was invented, the NLP area is more ruled by the linguistics, meaning that they're looking into the language characteristics, they're writing linguistic rules to actually solve the NLP tasks. But then with the word embedding, we totally jump into the area of deep learning and using word embedding to do a lot of fancy things. So what is in word embedding? A word embedding you can consider is a vector that each word can have, and you can see in this space, each of the word will occupy a point in this space. The amazing thing about word embedding is that although it's just a vector, it actually contains a semantic meaning of that word. So what you can do is that you can, if consider each word is a vector, what you can do is you can do an equation like him minus man plus woman, and that vector, what you get at last is actually queer. So this is the amazing part of word embedding. So I tried it on Chinese, and you can see that this is I trained on a certain area of documents, and you can see that if I put this is Guan, I put input Guan, and I find the most similar words. You will see that it's all about guns. So traditionally, what you can do is you can only do the character similarity matching, right? You can only see all the words with a gun in it will be related. But as you can see, you also find knives, you also find different types of weapons here. And same for here, that you search for hammer and you find all kinds of hammers and knives in there. So that's the amazing thing of word embedding, that it contains the semantic meaning of that word in that magic vector. And the way you train algorithm to get such a kind of vector is through this shallow neural network. I'm sure you're gonna find a lot of related materials on the internet. So with that word embedding, from my point of view, the overview of NLP tasks can be actually divided into these four main categories. The first one is that you're starting from a category and you are generating a sequence. Example of this category is like text generation. You gave a topic, and the algorithm will automatically generate you a text. Or you input an image, and the algorithm will automatically tell you the caption or the description of that image. The second one would be sequence to category. Example would be text classification. So you input a piece of news, it will tell you it's about sport or it's about politics or other things. Or sentiment analysis, where you just input a news and will or a comment. If you buy from Shopee, it will give you that comment is positive or negative. And one important thing I will cover later is about relational extraction. So you're input a sentence with two entities, and you try to find what's the relationship between that two entities. The third category would be from sequence to sequence and is synchronized. Synchronized means that while you are inputting that sequence, it will in real time getting you that output sequence with each part of the input that you have input into the system. Some examples are tokenization, part of speech tagging, and semantic role labeling. And one important example is entity recognition, where you input a sentence or article and you try to extract the important entities out of it. As you can see, here is an example that we're using Spacey package to extract the important entities like the corporation names, organization names, or person names. The last one is still sequence to sequence, but from an asynchronized way, meaning that you input a sequence and the system will wait until you input the whole sentence before it gets you the output sequence. So some examples will be like machine translation, text summarization. Text summarization basically will input an article, it will output a small paragraph or a short sentence that try to summarize your article. A very interesting application for this category is actually Pinyin Input method. So if you speak Chinese, you are using a bit of Pinyin as your input method, you will know what I'm talking about. You're inputting a bit of the English characters and you'll try to get the Chinese characters out of it. So this is the overview of NLP tasks. Of course, there are other tasks like clustering and some unsupervised learning part of the NLP. But for my talk, I will try to focus on all this. And all of that mainly are about supervised learning, meaning that you will need label data as input for all these tasks. So the first one I'm going to talk a bit is about entity recognition. By the way, of all these titles, I will put my GitHub repo here, the link here. So basically, most of the work I present today is actually open source. So if you're interested, you can just go to GitHub and check the work there. So this project is doing entity recognition using IDCA and CRF. So CRF is conditional random field. So traditionally, before deep learning, people use only the conditional random field to do the entity recognition. But now with word embedding, with deep learning, we are actually using this iterated, dilated convolutional neural network to do that. The reason that we use this dilated, so first, what is dilated convolutional neural network? It basically means that you start from an area, but instead that you cover each one that is adjacent to it, you actually skip one of in between so that you cover a bigger area. And next step, you skip like 4 of it, so you cover even bigger area. So this gap is actually exponentially increasing. The reason we do is that for the traditional convolutional neural network, if you want to cover the whole area, you have to have a very, very deep structure so that it can cover the whole area. And that will cause a lot of overfitting and cause a lot of, so you're going to have to use like dropouts or some other techniques to actually overcome all that difficulties. But with IDCAN, as you can see, you can just use 3 layers to already cover such a large area. So this is an example from a computer vision area. So if we're talking about a sentence, it will be a one-dimensional sequence, and this will be very similar to this one, but on one-dimensional. You can see I skip 1, I skip 4, and then I skip 8 here. So skip 2, skip 4, skip 8 here. So this is the way that we do it. So the input of the sentence will be here, and the output of that of this neural network will be here. So I use this structure to do the entity recognition to try to extract the entities from the sentences. And here is a bit of examples here. Sorry, it's a bit small, but it's quite amazing because if you think about it, if you're actually doing this entity recognition with a rule-based system, you're going to have to write a lot of rules. But with the deep learning method, with enough training data, you can actually get a very amazing result here. For example, it says Putin and Trump got a call, and you can see the Putin is here and Trump is also here. But of course, you can see a bit of error here, which he put another character after Trump as part of the name. But you can still see that all the company names, all the person names all these different kinds of entities can be extracted from this structure instead of writing a lot of rules. So this is very elegant and data-driven. The second example would be to do the relation extraction. So what is relation extraction? You think of that with one sentence, you already have extracted two entities. Let's say you have extracted Trump and President Xi, right, or another character, and you want to find the relationship between them. So that is a relation extraction. So the way we do it is we're using by GRU. So GRU is actually a simplified version of LSTM, and we're using the bidirectional way of that. We are actually also put a lot of the attention there. So both on the character level attention and also on the sentence level attention. But one important thing is that how do we get the training data? If you want to do a relation extraction, you need to have a lot of examples of one sentence, multiple entities, and the relation of it. So how can you do that? The way you do that is what we call the distance supervising. So basically, you try to find some famous people. So if you know Chinese, you probably know this Andrew Baby and Huang Xiaoming, who are both very famous actor and actress, and they're actually husband and wife. So what we do is we try to find all the sentences from the internet that contains Huang Xiaoming and Andrew Baby, and use all those sentences as the example of showing that the relationship is actually husband and wife. So in that way, you can actually crawl a lot of training data and use this network structure to actually train such a model. So this is a bit of the result. As you can see, I try to be a bit naughty here. Try to put a bit of different sentences here to test the algorithm. So this one is like this SE is the first guy A is responsible for the coding, and the second guy is responsible for writing the paper. So what are their relationship? The most probable relationship is cooperation. But you also find like a reporting line here. So probably in the real examples, who are responsible for writing would probably be the professor, and the first one would probably be the student here. And you can see a lot of different example here. So they are all spontaneous examples that is written in a very human way. So imagine that you're doing this relation extraction from a rule-based system. You're gonna have to write a lot of rules to actually achieve this kind of results. But with deep learning, with a bit of training data, you can already get a very nice result here. So with integer recognition and with relation extraction, what can we do? The most obvious one is actually we can construct a knowledge graph out of it. So you can do integer recognition, and the entities will be the nodes. You can do relation extraction, and the relations will be the links. So basically, if you are doing both from articles, the articles can become something like a graph. This is a bit of example that we did, extracting all the names from an article and try to build a knowledge graph out of it. There will be a lot of applications based on knowledge graph. For example, some visualizations, explorations. For example, you want to check what's the relationship between Trump and another guy with this huge knowledge graph. You can actually trace or find the shortest path in between it. Then you have a lot of graph-based algorithms. For example, how do you calculate that shortest path? It's actually a very difficult problem if you're considering a very large graph. And last but not least, you also have graph database development. There are currently two kinds of graph database. One is relational, and another one is NoSQL. I think the most famous graph database now is actually I don't remember the name, sorry, but yes, Neo4j. It's a commercial one, but it's a lot of people are using it. But of course, you also have a lot of open source graph database out there. So this is knowledge graph, and by the way, knowledge graph can be a very important database to support the chatbot that you are building. So if you're if you're building a chatbot, the chatbot wants to respond something that he wants to extract data from the database. Knowledge graph can be just that database that you're extracting knowledge from. Another example would be natural language understanding. So this is a very good open source project, RASA. And what I did in this repo is actually I tried to extend their very nice natural language understanding work to Chinese language. So the NLU, which I will talk later, mainly contains of entity recognition and intent recognition. So you try to find the who and what that sentence is talking about and what intent it intends to do. So I will cover this later, but basically there are a lot of online services with RESTful API here. Of course, Dialogflow from Google is a very good one. You also have from Microsoft, Facebook, and Baidu, but all of them are actually deployed in the cloud, and you have to call from the cloud. So if you want to deploy such a system in a private environment, you might want to check out REST. Another example would be to build a Pinyin method. So in this project, what I tried is I tried to use the sequence-to-sequence model to actually build a Pinyin input method. The structure is like this. You have a lot of like batch normalization. You also have highway links here. So this is actually an old structure that Google used for its machine translation, but it's still, we tried it on Pinyin input method and it works pretty well. The good thing about this project is that you can actually get unlimited training data because whenever you have a Chinese character, you have packages that can convert it back to the English Pinyin there. So our task is converted back, which is very hard. So you can see that I trained it on some old news article, and I tried it with input the Pinyin and try to find the Chinese character, and it works pretty well. And also, if you try to make some mistakes in the Pinyin method, it can still it's quite error prone, right? It can still try to detect the error and give you the correct Chinese sentence. So the project repo is still here that you can try to check out. So I've showed you a lot of different neural network structures, right? The IDCNN, the by GRU with attention layers, the sequence-to-sequence models, all these different structures. So which neural network should I actually use if you have an NLP tasks that you want to solve? So for computer vision, what you have is actually a lot of pre-trained deep learning models like VGG or Inception. So what they are is basically they're training on data sets like ImageNet, and they get a very, very nice base model. It's quite large, but it's a very good base model. So if you have a new computer vision task, you can basically just add a new last layer there and just fine-tune that model. You can phrase all these pre-trained models, but just fine-tune the last layer for your certain task. So this is already quite popular in computer vision. For NLP, we actually only had some pre-trained word embeddings. So with word-to-vector for fast tags, can we actually have pre-trained deep learning models? The answer is actually yes. So I think 2 years ago, we have this BERT, which is bidirectional encoder representations from transformers. And of course, you also have some other structures followed by this one, like GPT-2 and all that. It's very large. It has like 24 transformer blocks, 1024 hidden layers, and you actually have 340 million parameters. So it's huge. It's a huge model. But the good thing is that it's exactly like computer vision. You can now build NLP models. Just use this BERT model as your base model. And once this BERT was published, it actually won 11 language tasks, including GLUE, multi-NLI, and Squad. So I show you a ranking of the Squad here. So this is right after several months after BERT was introduced. Actually, I think BERT was introduced by Google, but you see that already after several months, Google is only number 5 here. And you can see, so this is a ranking of a competition there, and you can see a lot of different companies, they're actually ranking much higher than Google. So I think it's a tradition that the Chinese companies are really good at standing the shoulders of the giants, right? So the giant is here after he introduced BERT, then the Chinese companies, we can actually quite quickly develop all these models based on it and actually perform even better than the original model. And what's more interesting, you can see that Pinyin here. So Pinyin is actually an insurance company, but it's actually have a position here in the technology competition there. Yep. So that's part one. I hope I gave you a quick introduction of what NLP is and what kind of projects we're working on. The part two would be for Chatbot. So the first thing I want to ask, so when you try to build a chatbot, the first thing you have to ask yourself is, do you really need to build a chatbot? If your context, by the way, the chatbot I mentioned here are all task-oriented chatbot. It's not chit chat. So if you're looking for chit chat solutions, it's a totally different thing. And you can probably build a nice chit chat chatbot just with sequence to sequence model. But here, what we're talking about is task-oriented chatbot, where you really want to solve a problem for your customer. So if your context is that you have an interaction with a single target and the steps and logic are quite clear, then don't use a chatbot. I show an example here. This is from McDonald's in Hong Kong. You probably also have that in US or in Singapore, where you just go to McDonald's and they have this nice screen. You can just click and get what you want directly from that screen. So don't use the chatbot for that use case, right? Because it's so clear, the steps are so clear. You don't really need a chatbot for that. But what chatbots is really good for, first, it's good for customer service in the vertical domain. You really need to have some domain knowledge to actually solve the customer needs. Second, if you have a lot of similar questions and inquiries, then the chatbot can actually learn from the questions and give you a good answer. And the targets needs to be clear or at least semi-clear, but the customer may need a bit of guidance there. But that will be where the chatbots performs. What's the advantage of a chatbot is actually it can automatically get the user profile, so it knows what you need. It can actually give you the personalized recommendation. It's instant read from vast relevant knowledge base, so it can actually have a very knowledgeable or a very large knowledge base in the backend to support its answers, and it can give you the personalized answers through multi-round dialogue. So suppose you don't really ask your question right in the first round, it will try to lead you to make you clear what your questions really is, and then give you the right answer here. So chatbot is actually not a new thing. We already had chatbot for a very long time. The traditional chatbot is actually mainly built by two ways. The first method is you just build a chatbot with a set of rules. So I'm actually putting the example here. It's developed with the AI/ML language, which is a rule-based language specifically designed for chatbot. So I put the demo, the repo also here. So if you're using a set of rules to actually create this chatbot, it will give you very high accuracy, meaning that when you get the question, if you know, you really know. But if you don't know, a lot of the questions, because the customer may ask you a question in a lot of ways. So if you don't know, you don't know, and the recall will be very low. There will be hundreds of expressions from the user just for one single intention. So you can imagine that it's really difficult to write all the rules that cover all that intention. So, and also if, with the internet, a lot of new expressions are coming out, and it is really difficult to maintain such a rule-based system. Another way is actually to use semantic similarity. So you always try to match the question from your user to a database of all the questions. This method, you will need a very large quantity of data, and the accuracy is actually quite low. So what we do now is actually using a bit of machine learning to actually build this chatbot. From my point of view, the current mainstream chatbots architecture are basically composed of these three different modules. First is the natural language understanding. Remember, I talked about Rasa NLU. That's what it solves this part of the problem. And the second one will be dialog management, which try to manage your dialog flow, try to understand your question in multiple rounds, and try to extract that information from the database. And the third one, the last one, would be natural language generation. So we know your question, we get the correct ingredients to compose of this answer, and we will try to generate that results in a natural language way. So that's the NLG does. So first, the NLU. So I show here actually a basic structure of normally what an NLU does. So basically, you have to do a bit of pre-processing of the questions, the user input. And then you have to do two tasks. One is you have to figure out what the intent that your user is going is asking. So that's a text classification problem. And then you need to figure out what kind of entities are within that question. So that's a sequential labeling problem, or that's an entity extraction problem. Traditionally, you do a lot of that. This is bunch of stuff is what I talked about, the linguistic features. So traditionally, you use a lot of manually made linguistic features, and you go through some traditional machine learning algorithms like logistic regression or supporting vector machine, and you achieve this too. But with the development of deep learning, you can also do it with word embedding and with some deep learning structure. But very importantly, that for most of the NLU system, you also have a rule-based system here, which supports the machine learning part. So if the machine learning part finds that the results, the confidence is really low, so it will basically revert back to the rule-based system, and rule-based system will try to find some keywords and try to match some rules to actually give you that intent and entity. So I give some examples here. So basically, this is, I want to find a shop for noodles. So if you input that, the NLU will give you, okay, there is an entity here that which is noodle. So you are trying to find noodles, and the intent is actually you're trying to find a restaurant here. So this is an example of a Chinese NLU here. Of course, you need to do a bit of system integration. So with the NLU, you have to put it in the service layer, but under the service layer, you also have a storage layer where you have all that user input data, you have the model, you have the training data, and sometimes you have a bit of the index in there. But upon the service layer, you then have a nice interface layer where you can do system configuration monitoring, or you can have a bit of user interaction. And it will cover, you will have a UI for like API monitoring, model management, and data management. So later I will show you a demo of the tools that we built, which is basically built with this infrastructure here. And of course, the service layer can give API to the interface layer, but also can expose this API to some other services there. The next module would be Dialog Manager, so which is here. So the Dialog Manager basically do multi-round dialog management, and it will do knowledge base query from the knowledge base to get the correct answer, and it will try to maintain the current dialog status. So imagine you're asking a question, but you don't really ask it, you don't really provide all the information to the bot, to the chatbot yet. So the chatbot will try to lead you to get to give the bot all the information that the bot needs. Example is here, the user asks, the kid is sick, what should I do? So then we first go to NLU entity recognition, so it's sickness. Then we do entity extraction, so it's a child here. The Dialog Manager finds out, okay, there's no age, no symptom, and no gender for the kid. So then we go to the natural language generation and generate this question. So how old is your child, boy or girl? The user will answer, okay, 6 months boy. So the entity recognition finds it's 0.5 years old, it's a male. But the Dialog Manager finds, okay, still no symptom here. So again, natural language generation, what symptom does he have? He's having a fever, the user answered. So the entity recognition will find fever. And now we have all the information, right? And then the Dialog Manager will do a query on the knowledge base, define and finish the task. And then it will show, okay, please call Dr. Chai at a phone number. So this is basically what Dialog Manager does, and also give you a bit of sense what natural language generation here does. As here, you can see the main tasks of Dialog Manager. So it will do status management. So it will try to manage the current dialog status, user history, bot history, and possible answers from the knowledge graph, from the knowledge base. It will maintain a multi-round dialog. So it's a user's intent clear, it's intent information enough, and it will try to query in a guided conversation. It will also execute, so it will try to put NLU result into database query, and it will put NLU results into a task execution. Whether you're buying from a shopping from online shopping, so it will add to shopping cart, or it will call someone's number. And of course, it will have multiple ways of implement this Dialog Manager system. But this is kind of, there's no standard work regarding to this one. So some people do it in a rule-based way. Some people do it as a supervised learning part, as a sequence labeling problem, because you have a dialog sequence there. And if you have enough training data, you can actually consider it just as a sequence labeling problem. And you can use deep learning and all that to actually train the Dialog Manager model. And also some people are actually using deep reinforcement learning to train the Dialog Manager. So you have some user simulator that tries to answer the question from the bot, and both parties will actually interact with each other and try to maintain a reinforcement learning infrastructure to actually train such kind of a model. The last one is natural language generation. So this one is also it's very important, but I won't cover it too much. But there are basically two ways. The first one is templates. So you manually generate template sentences with some entity slots. It's basically a template filling problem. Another way of doing NLG would be data-driven. So you have a lot of training data. You can actually train a sequence-to-sequence model to generate that language. But it's now here, it's actually trying to learn that templates with the entity slots. So you try to use NLG to generate that template, but you just fill in the entity slots from the knowledge base. A lot of the system currently are actually using a hybrid way of both two. But the most recent or advanced research part is actually how can we, instead of having all that different modules, can we build an end-to-end chatbot of the whole modules just based on deep learning? So there are actually research works on that. So for NLU, DM, and NLG, each module can actually be DL-based. So this is example here. Sorry, I didn't put the link to the paper here, but if you are interested, you can definitely check out from the internet. And there are also some other works for memory network, which is instead of having a separate knowledge base or separate database, we're trying to embed the whole knowledge, the whole knowledge just into that model, just into the model parameters. So that's also quite a frontier research there. But what I see is I still don't find a lot of real applications using this kind of techniques. Mainly, it's still from academic research point of view. So yeah, I hope it just gave you quite a quick overview on the chatbots. And here I want to show you a tool that we built. It's a full pipeline UI for building a Chinese NLU system. We call it ChatStack. So I will quickly go through the slides and show you the demo. So ChatStack is a full pipeline UI for building a Chinese NLU system. You can define your intents and entities. You can label the training data. You can train the NLU models. You can manage the models, test and deploy NLU MPIs, and even do the dialog management without writing any code. So you don't have to write any code. Just use our tools with a nice UI. You can do all this stuff. And it is specific designed for Chinese language. Basically, for customization for Chinese language, you need to do tokenization because for Chinese, all the characters are stick together. It's not like English where you have the blanks in between the English words. For Chinese, it's all stick together. So you have to do a bit of Chinese tokenization first before you can run all the different algorithms. We have a domain dictionary. We have Chinese word embeddings. And we use all that customization algorithms for text classification and sequence labeling, as I just mentioned before for the NLU task. And we have an intuitive UI for data labeling. We also have a UI for user model and API management. So if you allow me, I can quickly give you a demo here. So this is the UI, the input part. So if I log in, as you can see, we have, sorry, it's all in Chinese, but if you read Chinese, you will find it quite easy to understand. So we have entity recognition here. So you have different intents that you can input here. You have entity recognition here, where you can define your entity here. So it's always UI that you can input and save. You can see all your training data here. So this is the training data that you have to input here. And you can actually also try to highlight the entities and try to label its intents there. We also have a production log. So you can actually have all the historical API calls, so what the users are actually calling your models. And you can also have the model management here. So basically, those are all the historical models that you built. You can see who built it, when you built it, and you can actually choose which one is a testing model and which one is a production model. Testing model is what you just testing here with this UI, and production model will be the model that you use for exposing the API for production systems. And of course, you will also have account management. So we give different access to different tasks. So if this guy is allowed to train an NLU, if this guy is allowed to modify the intent and entity, if this guy is allowed to change the different versions of NLU models, or change the training data, or look at the production log, or even reset your password. So all these different access rights, we put it in a nice UI where you can modify. So yeah, that's basically all my presentation. Again, I put on this cake. I hope you understand why I put a cake here, because the NLP is a very I would say a not solved problem. It's not like computer vision where you have already solved a lot of problems. For NLP, it's still, I would say, in a very initial stage. But you do see a lot of different algorithms that you can put together. And Chatbot is a great example of using all that different technologies to build a application. And hope that you find my presentation tasteful, just like the cake here. Again, if you're interested, you can reach out to me either by email, GitHub, LinkedIn, or you can check out my blog here. That's all from my presentation. Thank you.
Hey, Guan, thanks for the insights that you've provided us today in that 3-part presentation. I think that was a very awesome presentation. If there's anyone who has any questions, we have one question. Okay, so let me just repeat this question for the audience. So from Songhan, could you share a bit more on the challenges of working with Chinese language for NLP problems as compared to English?
Yep. So very obviously, if you look into the academic research area, most of the research on NLP are based on English language. The training data, the academic research data, and algorithms are all designed specifically towards the English language because it's a global language. So the main challenge for working for Chinese language is to find such kind of good training data or good data that you can at least test on your algorithms. So that's a main challenge. There are also a bit of technical challenges, like I said, for example, the tokenization of the Chinese the Chinese sentences, because all the characters stick together instead of like English here, you have blanks in between them. So that's an example of the technical challenges that we have. But one way we solve it is we're trying to, instead of use word embedding, we're using character embedding. So each of the character of the Chinese character is actually a unit for that embedding vector. And it turns out it actually works pretty well. So you don't actually need to do a tokenization. You don't need to do tokenization before you really run your Chinese language algorithms. Good.
Are there any other questions within the audience? So I do have one question.
Yep.
Can you hear me?
Yes.
Okay, I do have one question of curiosity, which is, so it seems like you are very advanced, very experienced in this topic, and you being also a GD as well. So I think maybe this is also sort of like carrying on our last speaker's part of what he introduced. Are there any recommendations you would give towards, let's say, beginners in the audience on how they can start with picking up ML?
So if you're just talking about machine learning, definitely there are a lot of free training courses there. So I personally, when I started my career of data scientist, I personally learned most of the knowledge just from Coursera. You have excellent courses from Andrew Wu, from University of Washington, from a lot of experts in machine learning just on Coursera. So if you are just a beginner, you should definitely check out Coursera or some other platforms. Most of the content are actually free for you to learn. But once you've gained a bit of concepts that you understand what machine learning is, I strongly recommend recommend you to go to GitHub and check out the other projects, because if you don't do hands-on, then you are not really in this area. You're not really doing data science or machine learning. So I highly recommend you to go out there to check out the different repos, different projects from others on GitHub, and try to read their codes or even modify a bit of their codes and run your version of that and check the results. That's my recommendation. Yep.
Nice, I agree with that. Yeah, hands-on learning is always definitely the best. I think we have one more question, so let's take one more question over here, which is from Saurabh. What are resources to start with Chatbot using GCP along with ML that you would recommend?
Yep. So if you're using talking about Google Cloud, you should definitely check out Dialogflow. Dialogflow is a product or a service provided by Google. It's actually quite similar to what I just showed you in my demo there. But if you're, like I said, if you want to try some algorithms or try some NLP projects by your own, you can just apply for a Google virtual machine there and try to code from scratch. The Google Cloud have very nice GPU support where you can train deep learning models. And I think if you register as a new user, they even give you like a bit of free credits for you to start. But just a word of warning, if you try to deploy a TPU environment, it will cost a lot. I tried to deploy a TPU pod and it basically used up all my credits just in the weekend. But still, it's a very nice platform that you can try there. Yep.
Nice. Hey, thanks again, Guan, for your insightful talk as well as your answers that you've provided for our audiences as well. Thanks again.
Thank you.
Yeah. Okay, so let's move on